Hello again, everyone. This is lecture 7 for about the order of operations, and we will get started with that now. Okay, so there is a handy little acronym for, oops, sorry, that was not what I wanted to do, for the order of operations to follow. You may have heard before. Please excuse my dear Aunt Sally, or as I've heard in college, push Eddie Murphy down a staircase. Whatever you prefer, however you decide to remember it is completely up to you. So we have, please excuse my dear Aunt Sally, or push Eddie Murphy down a staircase. Either way, you want to remember it. Both ways have stuck with me for longer than I care to admit. Okay, so what this stands for is parentheses, exponents, okay, I don't know why that part of the screen doesn't want to work, multiplication, division, addition, subtraction. What's important to note about these is this is the order you have to go in, but parentheses and exponents are completely separate from all the other ones and from each other. So if you want to like box them off, these ones are separate from each other. So they have to be done in that order, parentheses and then exponents. Whereas multiplication and division are considered to be on the same level or of the same degree of importance. So if they're both involved in a problem and it's only multiplication and division, you just work left to right. You don't have to do multiplication before division. You can do division before multiplication if it comes first. So that you can move through it like that. Addition and subtraction are the same way. They're considered to be on the same level of importance. They're not necessarily separate from each other. If you are only left with multiplication, or I'm sorry, only left with addition and subtraction, you can just do them left to right in the order that they appear and work like that. The same rules for, multiplying negatives and positive negatives, multiplying, dividing, everything that we've done before, adding, subtracting still applies. This is just when you're dealing, or is just a method to deal with problems that have all of them together with you. So like that, it would just describe how you do them. And it's also important to note, like in number 1, when you see a fraction, that fraction is division, but it has to be done at the very end, because essentially when you see a fraction like that, like say you have like, no, I didn't want to put that in there. Okay, so say you have a fraction with numbers, you have like a times b plus c minus d over e plus f. If you were to write this in the standard division form, since you're separating with a whole fraction bar, it'd be like saying a times b plus c minus d, all in parentheses, divided by e plus f in parentheses. So you'd have to evaluate both of these expressions first, or you'd have to multiply the numerator and the denominator separately first before you do the last division, which is represented by that fraction bar. So just something to keep in mind when you see a fraction is you have to evaluate it in that way. Okay, so we have all of these rules. I'm going to erase the spaces under them so that we have that room, but I'll keep that acronym up there for everyone. Okay. Sorry, that took a little bit longer than I would have liked it to. Okay, so for number 1, we have it reads 7 times 11 the quantity 11 minus 6 plus 4 times 2 divided by -5 times the quantity 3 minus 8. So what we have here to solve this, we'll start with the numerator and then go to the denominator. You can do those in either order that you like. Doesn't matter. Just evaluate them separately from each other. So what we have to do in the numerator first is simplify what's in parentheses. So then we'll have 7 times 11 minus 6 is 5. So we have 7 times 5 plus 4 times 2. And then if we evaluate the denominator now, we have to evaluate what's in parentheses first. So we have -5, and then 3 minus 8 is also -5. So you have -5 times -5. Okay, perfect. So now in the numerator, we have multiplication separated by addition. And as we can see in order of importance, it goes parentheses, exponents, multiplication and division, then addition and subtraction. So we have to do multiplication before we do addition and subtraction. So now we have 7 times 5 is 35. 4 times 2, still separated by addition, is 8. And then in the denominator, -5 times -5 is a positive 25. Okay, perfect. Now all we have to do before we do the final division or see if we can simplify anymore is to do 35 plus 8, which equals 43. And then the denominator just stays the same because it was already combined. So we can't really simplify this at all because they don't have any common factors. We can't divide nicely, so we can just leave it as an improper fraction of 43 over 25. Okay, perfect. Okay, so moving on to number 2, we see we have some brackets. Well, brackets are just like another like set of parentheses. Essentially, it's just so you don't get confused with the with what's already there. So they're an overarching pair of parentheses. So they cover this entire expression except for the 9. And then we have another pair of parentheses on the inside that just covers 7 minus 2. So when you see a situation like this, you always want to work from the inside out. So we have to start this by evaluating 7 minus 2 in parentheses. And you always want to, what I essentially want to say is you always want to work from the innermost parentheses to the outermost parentheses if there's multiple sets of parentheses involved. So first we have to evaluate 7 minus 2. So we have 9, and then in brackets 11 plus 5, and then 7 minus 2 is 5. So we have 5 times 5, and then close brackets. So this would be, and then now we have to evaluate what's inside the brackets first before we can multiply the 9 in. So we have 11 plus 5 times 5. Well, multiplication comes before addition. So we have 9, open bracket, 11 plus 5 times 5 is 25. So like, you can't have the 9 in yet because 9's multiplication next to parentheses. Parentheses still come first, and that's what we're doing. We're evaluating what's inside parentheses before we multiply it to the 9. But then also, if you have a dynamic expression like we do inside of the outside parentheses, you have to still apply the order of operations even inside there. Like you just have to still apply it there too. So then we have 9 times 11 plus 25, which is 36. And then we're just left with 9 times 36, which we can evaluate, which is 324. Which you can use a calculator to get there, or you can use standard form of multiplication like I did previously, with on my scratch paper, which is 36 times 9. We have 9 times 6 is 54, so we carry this 5 up to add. And then we have 9 times 3 is 27, plus 5 is 32. So we have 324, which is what we got. So that works out for us. Okay, it works. The order of operations works just the same as with variables. Variables next to a number just represent multiplication, although we can't really carry out that multiplication just because we don't know what's being multiplied. It's just a variable. So you can just leave those alone. But you still have to carry out the order of operations as normally, as best you can. In the case where there's variables here, we have 4z plus 13x. Since z and x aren't the same number, we can't add them together because they're not the same quantity, they're not the same variable. So what we can do, since this negative is outside of these parentheses, this -1, because negative times something is like -1 times something. So what we really have is 22x plus -1 times 4z plus 13x. So what we can do is we can distribute this -1 inside to both the 4z and the 13x. So then we'll end up with, oh my goodness, the stylus is not happy today, 22x -1 times 4z is -4z. -1 times positive 13x is -13x. And then from here, we can rewrite this to combine like terms, because addition is commutative, addition, subtraction. So we have 22x. This -13x can be moved as long as we move the negative sign with it. So we have -13x. And then -4z. So since the 22 and 13 both have an x attached to them, they're considered like terms. They have the same variable, so we can combine them. So 22 minus 13 would be 9. So we're left with 9x minus 4z as our final answer. Okay, and then in the next one, we have 2 times the quantity, 14 plus 7, divided by 3. Okay, so in this one, like I mentioned before, parentheses come first, no matter what. They're the first thing you always do. You evaluate what's inside parentheses before you do anything else, if possible. We have 14 plus 7 inside parentheses, so that would be 21. So we'd have 2. Oh my goodness, this stylus is driving me crazy. Times 21 divided by 3. Well, the 21 is just a single number now, so we can drop the parentheses. So we can have 2 times 21 divided by 3. Okay, so here's the situation like I was talking about before. Multiplication and division aren't separate from each other. One isn't more important than the other one, or in terms of the order. So we apply the convention. Oh goodness gracious! Can we work with me, please? The standard convention now of just moving left to right, because we only have multiplication and division left in this order of operations. We don't have anything else. So we'll just evaluate this left to right and carry out that multiplication first. So 2 times 21 is 42. So we have 42 and then divided by 3. And then 42 divided by 3 is 14. And that would be our final answer here. Okay, so in the last one, we can see that we have, oh my gosh, this thing is going to make me throw hands in a minute. We have parentheses. We have the whole quantity, 13 plus 7 times 15 divided by 3 plus 32, that whole quantity times 4. So we have to evaluate what's inside parentheses first, but like I also mentioned previously, when you have multiple things happening inside parentheses, you have to follow the order of operations also inside the parentheses. So we can see that we have addition, we have multiplication and division and more addition. So we have to evaluate what's inside parentheses first, but in doing that, we have to evaluate the multiplication and the division first. And since the multiplication and division are next to each other, neither is more important than the other, we're just going to move left to right. So first, to simplify, we have in these parentheses 13 plus 7 times 15. Well, over here we can do that. 15 times 7, that's 35, so the 3 gets carried up here. 7 times 1 is 7 plus 3 is 10, so we have 105. So we have 13 plus 105 divided by 3 plus 32 times 4. Okay, so for 105 divided by 3, if you don't know what it already is, we can do long division to figure it out. 3 doesn't go into 1, but 3 does go into 10 3 times, which gives us 9. 3 times 3 is 9. If we subtract, we get 1. Then we bring down this 5. Then we have, how many times does 3 go into 15? Goes in exactly 5 times. So we have minus 15, which gives us 0 as a remainder. So this would be 105 divided by 3 is 35. So this is 13. Oh, I'm going to rewrite that because this just kind of tripped out on me. Okay, so we have 13 plus 35 plus 32 all times 4. So we still have to evaluate what's in parentheses, but we can just add all of these things together now because we just have addition left. So we just go left to right and add them all together. 13 plus 35. Actually, we can probably just, we'll do that addition. I'll demonstrate it here. So we have 13 plus 35 plus 32. So if we evaluate down the ones column first, we have 3 plus 5, which is 8, plus 2 is 10, so we have to carry the 1. Then we have 1 plus 1, which is 2, plus 3, which is 5, plus another 3, which is 8. So now this becomes 80 times 4. But since it's just 80, it's a single number now, we can drop the parentheses. So we have 80 times 4. So if we do that, if you prefer this way, you can do it this way. 4 times 0, 0. 4 times 8 is 32. So you get 320. Alternatively, since there's 0 in the ones place, you can just think of 8, or you can have a 0 placeholder for that ones place. And then think, what's 4 times 8? 32. So it's 320 as our final answer. And that would conclude this video. I hope you found it helpful, and I will see you next time.